Hello friends, today we take up measurement of mass. Last time we have seen how lengths of different sizes can be measured, and today we will discuss how measurement of mass can be carried out. Before we proceed for measurement, let us differentiate between mass and weight. Point by point we will take up the difference. First we take up definition. Now what is mass? Mass is quantity of matter contained in a body. What is mass? Quantity of matter contained in a body. And what is weight? Weight is the force with which the body is attracted towards the center of earth. It is expressed as W is equal to mg, where m is mass and g is acceleration due to gravity of earth. Now second point, we take up type of quantity. What type of quantities mass and weight are? Mass is a scalar quantity, weight is a vector quantity. The third point, we'll take up SI units of mass and weight. Now SI unit of mass is kilogram and SI unit of weight is Newton or kg meter per second square. Now fourth point, we discuss about constancy of mass and weight. Now mass is constant throughout space and is independent of temperature and pressure, whereas weight varies from place to place because g varies from place to place. I repeat, mass is constant throughout space and is independent of temperature and pressure, whereas weight varies from place to place because g varies from place to place. Now fifth point, about zeroness, zero value of mass and weight, how we can understand about it. The mass cannot be zero for any material body. If material body is there, it must have mass. That is, mass cannot be zero for any material body. But weight can be zero, where g is zero, because W is equal to mg. If g is zero, W will be zero. So weight will be zero. For example, number 1, at the center of earth, g is 0. So weight at the center of earth is 0. Number 2, in free space, again g is 0. So the weight in space is also 0. So this is how we can differentiate between mass and weight. So point by point we can discuss and compare and discuss. Now what is inertial mass? Let us define. Definition of inertial mass is like this. When a body is in translational motion under the effect of external force other than gravity, the mass of the body is said to be inertial mass. I repeat, when a body is in translational motion under the effect of an external force other than gravity, the mass of the body is said to be inertial mass. For example, consider two bodies, bus with mass mb and a cycle with mass mc applied with same force. If they acquire translational motion or their speed varies, then they possess inertial mass. Okay. Now another definition of inertial mass. The characteristic of the body that determines its response to an external force in accordance with Newton's second law of motion is also defined as inertial mass. I repeat, the characteristic of the body that determines its response to an external force in accordance with Newton's second law of motion is also defined as inertial mass, that is F is equal to ma. Now, for example, consider two bodies, bus with mass mb and a cycle with mass mc, applied with same force. Okay. Now, since an external force produces an acceleration in the body, let acceleration produced in the bus be AB and cycle be AC. Therefore, for both we can write F is equal to MB AB and also F is equal to MC AC, because force applied is same on both. Because MB is more than MC, therefore AB is less than AC. Therefore, we can write AB equal to MC by MB into AC. Therefore, we can write AB is equal to MC by MB into AC. Thus, bus has more inertia and cycle has more acceleration. Because MB is more than MC, therefore MC by MB would be less than 1. It means AB is less than AC. That is, bus has less acceleration, cycle has more acceleration, bus has more inertia, cycle has less inertia. Now we talk of gravitational mass. What is gravitational mass? Let us define. When the body is under the effect of gravity but without motion, the mass of the body is said to be gravitational mass. I repeat, when the body is under the effect of gravity but without motion, the mass of the body is said to be gravitational mass. Consider two bodies marked as 1 and 2. This is body 1, this is body 2, under the effect of gravity as shown. They are separated by a distance r. Let m1 be the mass of body 1 and m2 be the mass of body 2, then weight of the body 1 will be W1 equal to m1g. Let us mark it as equation 1, and weight of the body 2 will be W2 equal to m2g. Let us mark it as equation 2. Thus, under the same conditions, same place on earth and same altitude, the weights of the two objects are proportional to their masses. This mass is known as gravitational mass. Now, dividing equation 1 and 2, we get W1 by W2 is equal to m1g by m2g, and it is equal to m1 by m2. Our W1 is equal to m1 by m2 into W2. Since m2 is more than m1, therefore W1 is less than W2. W1 is less than W2. Another definition of gravitational mass, let us look at. The characteristic of the body that appears in Newton's law of gravitation, which is given by the expression Fg is equal to g m1 m2 by r square. I repeat, the characteristic of the body that appears in Newton's law of gravitation is also defined as gravitational mass. Now, according to Newton's law of gravitation, for the above situation with bodies of mass m1 and m2 separated by r, we can write Fg is equal to g m1 m2 by r square. Okay. Then we call it as gravitational mass. Now, value of universal gravitational constant, capital G. How we calculate the value of gravitational constant, capital G? Let us see. Consider a body of mass m falling through a height h under the action of gravity towards Earth. Consider a body of mass m falling from height h under the action of gravity towards Earth as shown in diagram. According to Newton's second law of motion, force experienced by it is F inertial is equal to mi into g. And according to law of gravitation, force experienced by it is Fg equal to g capital M mg divided by r plus h whole square. Now, because r is very large as compared to h, therefore h can be neglected in denominator, and the expression reduces to the form Fg equal to g m mg divided by r square. Okay. So, we are to calculate the value of capital G from this expression. Since same body now we are to calculate the value of G. Since same body is under the influence of both the forces, therefore F inertial must be equal to Fg. F inertial must be equal to Fg, or mig is equal to g capital M mg divided by r square. Since body is in motion under the effect of gravity, therefore mi must be equal to mg, because body is same. So mi must be equal to mg. Therefore, above equation reduces to the form g is equal to gm by r square, or capital G is equal to small g into r square by m. This is how we can calculate. By substituting the value of g, r and m, we can calculate the value of universal gravitational constant. So 9.81 meter per second square is small g, into r is 6.380 into 10 raised to power 6 meter. We substitute here, and the mass of the earth is 5.976 into 10 raised to power 24 kg. On simplification, we get value of g equal to 6.6734 into 10 raised to power minus 11 Newton meter square per kg square. So this is how we can calculate the value of g. So you remember this value of g for doing numerical problems. Now, assignment 2.2 continued. Question number 12. Differentiate between mass and weight. Question number 13. Define inertial mass and illustrate with an example. Question number 14. Define gravitational mass and illustrate with an example. Question number 15. Calculate value of universal gravitational constant G. So, thank you so much for today. We will continue with this topic tomorrow and day after. Thank you so much.